Good morning, guys. Welcome to Unit 8.2. We're going to be talking about ambiguous cases today. This right here is just kind of going to open the floor for what we're discussing for today's assignments and notes. So let's say that you are given a triangle. Measurements A, the length is 10, leg B is 6, and angle B is 30 degrees. Okay, that could look something like this. Okay, but let's talk about what if I were to somewhat kind of just draw an equilateral triangle within this triangle. That would mean that these are the same length. That would mean that this leg is also 6. Couldn't this also be, using all the information correctly, A is 10, B is 6, and angle B is 30? It still could be the same, it still could be the triangle measurements. Well, how do we know if we use this one has an obtuse angle for A, this one has an acute angle for A? How do we know which one we're going to find and which one we use? Well, that's what we're going to be talking about today, because technically this could give us information on two different types of triangles, and that's going to lead us into ambiguous cases. So in an ambiguous case, you will get one of three different options. Number one being that no triangle exists. And when you plug in your law of signs into the calculator, you will find that it says undefined, and you'll know that no triangle exists. The other option is like what I just showed you, that there are two different solutions to the given information. And then the third is that there's only exactly one triangle possible made from what we are given. So I'm going to follow these steps below to show you how to find and solve each of those. All right, here we go. We're actually going to start with number 2 because it's going to be the easiest one, in my opinion, to just kind of go over and set the stage. So we are always, the first step, draw the triangle and label with the given data. Okay, I can definitely do that. Here on the side, I'm given a triangle, and it doesn't have to look completely accurate. However, we are just going to make sure to label everything correctly. So if B is 96 degrees, that means that this length here across from it is 3. All right, and then A is 24. So we're going to set that up like so. That means that A is here, B is here, C is here. All right, let's use our laws of signs in order to solve for angle A. We'll start with that. So we have 24 over sine A is equal to 3 over sine of 96. Okay, once we cross multiply, we're going to get 24 times sine of 96 is equal to 3 times sine of A. All right, when I plug that into my calculator, I get 23.61 is equal to 3 times sine of A. Once I divide by 3 here, we get that sine of A, I'm going to actually move over here and keep writing, is equal to 7.87. And that would mean that A is equal to the sine -1 of 7.87. Now, when you plug this into your calculator, it will not work. And I will go ahead and do it just to be sure. Sine of 7.87. My calculator says undefined. You might get an error in your calculator as well. So upon using the first, the second step to use the law of signs, there is no triangle. And technically, if B is 96 degrees, that means that between A and C, there's only 84 degrees between measures C and A. That would mean that maybe one of them 70 something, one of them could be 10 something. Either way, it's going to be less than 96 degrees. It's going to be shorter than leg B here. That would mean that since B has the greatest degree measure, that leg B would have to be the longest leg, and it's not, because leg A is longer than leg B, even though the degree measure for A would have to be shorter, would have to be longer than the 96 degrees, and that's impossible. All right, so let's move on to number 3, and then we're going to drop back to number 2. I'm going to go ahead and draw the picture. We have A is 7, and I will put an A in this corner. B is 9, and C, we don't know anything about C yet. B is also 49 degrees. And we'll put a little C here just to start with. All right, so we're going to start by finding measure A. So we have 7 over sine A is equal to 9 over sine of 49. So that means that sine A is equal to 7 times sine of 49 over 9. Okay, when we use sine to the negative 1, we get that A is about 35.94 degrees. Okay, we'll start there. That would mean that angle C is equal to 180 minus 35.94 minus the 49 degrees. Because a triangle is 180 degrees total, we've taken the two angles that we know and subtracted them from 180 to find what angle C is going to be, which is 95.06 degrees. I'm just rounding here. All right, now we have to find side C. So as we're completing the triangle, we're going to find everything. We're solving the triangle. So we have 9 over sine of 49 is equal to C over sine of 95.06. All right, when you plug this into the calculator, you will end up finding that C is approximately 11.88. All right. From here, we have solved and continued to find all the parts of the triangle. Now we have to find the angle supplementary to the angle opposite given side. So we have to find the angle supplementary to the 35 degrees that we just found. Well, let's start by doing that. So if A were 180 minus whatever we originally found for A, 35.94, it would be equal to 144 degrees, 0.056, somewhere around there. This would be our new A. All right, and if angle A is 144 degrees and angle B is still going to stay 49 degrees, because that's not going to change. The only thing we're changing is the measure that we found originally, angle A. And I'll refer back to this here just to show you why did we subtract the degree measure that we found from 180. Because if you look here, technically the acute angle we found and this angle of the supposed second triangle together will make 180 degrees. Okay, so hopefully that makes sense as to why we are subtracting what we found from 180 to find this obtuse measure of the second triangle. All right, now once we do that, we would do the exact same thing we did here. We take angle C would be equal to 180 minus the 144.056, and again minus the 49 degrees. Well, if we did that again, for angle C, we would end up getting a negative 13.056 degrees, and that is not possible. All right, so basically what you need to be sure of is that you find this first angle, solve the triangle. Okay, once you go back to that first angle and subtract that your original angle that you found from 180 to find the obtuse version, or sometimes the acute version, depending on what you first solve for, and then try to solve the triangle again. And at some point, it will either work or it will not work. And this is where, for us, it does not work. And now I will show you a case where you can completely solve 2 triangles using the steps above. So the first thing, draw the triangle. All right. We have 22.42 as A. Angle measure A, we don't know yet. We have 16.8 as angle measure B. And then C, we are not sure of yet. What am I missing? Oh, the 22 degrees for angle B. All right, so the first thing we're going to do is find angle measure A. We use our 22.42 over sine of A, which is equal to 16.8 over sine of 22. All right, that means that sine of A is equal to 22.42 times sine of 22 all over 16.8. Once you use our sine -1, we will find that A is approximately 29.994 degrees. Okay, from there, we can solve the rest of the triangle. We'll take 180 and subtract the new angle that we just found, 994, and subtract the angle that we were already given, which is the 22 degrees. Once we do that, we get that angle C is equal to 128.006 degrees. Now you can round to the tenths, that's totally fine. All right, and then we have to find side C, and this just is us solving the triangle completely just with what we've been given. We'll solve for side C. We've got 16.8, which is the length of B over sine of 22, is equal to C over sine of 128.006. Now, once we do that, we solve for C, we get 35.337. That completes the first step. We have solved the triangle. Now we have to find the angle supplementary to the original angle that we found, which was A. By doing that, we will take our angle A will be equal to 180 minus 29.994. And what we get is about 150.006. All right, that's our new angle A. That's our obtuse one that we'll be using for this. B is still the same. Angle B is 22 degrees. All right, and that means that angle C is equal to 180 minus 150.006 minus 22. Once we do that, our angle C is actually equal to 7.994 degrees, which is possible. It's not negative. It definitely works. And let's see what our new C leg would end up being, which is 16 over sine of 22. We've got leg B over sine of angle B is equal to leg C over sine of angle C, 7.994. Once we do that, angle C, we get approximately 6.2. So everything worked out. At some point, we would have seen something negative, something does not exist, some sort of error in our calculations, and that never happened. So you have one example above, number 1, where we were able to solve for 2 complete triangles. And then we have number 2, which is where there was no triangle. And then number 3, where there was 1 triangle possible. All right.